Okay, hello everyone. We are going to go over the outline notes that I gave you all in class. Um, I'm going to try for each section to do something similar, like this sheet right here. And if I'm ever absent for any reason, I don't know if I will be after this, but you never know. And so if I am, then I'll do a video notes. But this is how we're going to do it in class because I want to go over the definitions, make sure you all are clear with the definitions or concepts, and then just do examples because that's what, in order to understand statistics, you just need to do it. And the advantage of taking a statistics course, unlike other math courses, is that you can always find real world applications and real world problems to help understand statistics. Okay. So section 1.1 is really brief, so this shouldn't take too long. And it's just going over some general terms for statistics. Okay. So statistics is the science of conducting studies to collect, organize, and hopefully you can understand my writing, summarize, analyze, and draw conclusions from data. Okay, that's what statistics in a nutshell is. Okay, a variable is a characteristic or attribute that can assume different values, measurements, or observations. And if you've taken any other math class, algebra or higher, you've definitely heard of variables, right? And they change. It's variable. 3, data are the values that the variables can assume. Okay, so those are the values that our variables can assume. Those are called data. And when these values are determined by chance, the variables are called random. These are what we denote as random variables. We're going to be dealing a lot with different random variables. But just to give you some, and for those who haven't had me as an instructor, I use some abbreviations. So EX is for example. So examples would be the roll of a dice, right? That's random. It can either land, if it's a fair 6-sided die, it's 1 through 6, right? Or if we flip a coin. Okay, assuming it's a fair-sided coin, no heads on both sides, you either have heads or tails. So that's what we call a random variable, okay? And a collection of data values, they form a data set. Each value in the data set is called a data value or datum. Okay, we usually just say data value to represent that. Okay, and if you have to pause, the beauty in having a video, right? You can pause and write and just make sure you understand those. This is the hard, understanding definitions is going to be important in this class to make sure you understand the different definitions. Okay, number 6, a population. All right, that consists of all subjects, human or otherwise, that are being studied. Okay, so whatever subjects you're studying, if you study all the subjects, then that's called a population. If you take a subset of that population, then we call that a sample. So a sample is a group of subjects selected from a population. What we'll realize is that just by taking a sample, we can gain tons of information about the entire population. Okay, because of finances and funding, it can be difficult when you're doing research to study all. So if you want to, my research is on Black women in math, right? And Black women mathematicians, if I wanted to study all, although sadly there are not that many, so I probably could, maybe if I had funding, go all over the world and find those. I think we might be up to 200 Black women mathematicians. I can't remember the last count. But in general, you would take a sample, okay? Descriptive statistics consist of the collection, I'm looking at my notes, organization. All right, so let me say this. There are 2 main types of statistics that we look at, either descriptive or inferential. Descriptive can give us, and we'll talk more about that. That's, doing mean, median, mode. You're probably used to seeing that. Inferential is a little deeper, right? Your standard deviations and things you're making inferences. It's not direct, okay? But descriptive statistics consist of the collection, organization, summarization, and presentation of data. Inferential statistics consist of generalizing from samples to populations, making estimates, performing hypothesis testing, determining relationships among variables, and making predictions. Okay, so inferential, you can sort of see you gain more rich information. We're going to be doing both, and you can gain an adequate amount of information from descriptive statistics, but inferential, we really go a little deeper with our data. Okay, and inferential statistics involves using probability to make predictions and draw conclusions. All right, so the area of inferential statistics called hypothesis testing, which we'll talk about in this course. If you look at the syllabus, we have a lot to cover. Is a decision-making process for evaluating claims about a population based on information from samples. Okay, so these are just sort of foundational definitions that you'll need to help you understand where we need to go. All right, so I wanted to give you this example. So, the beginning of the new year, everyone's trying to work out, right? Yes, I am one of those people. And so I've been trying to go to the gym, let's say at least 3 to 4, really 5, I need to. But nevertheless, I wanted to give you an example of what descriptive statistics would look like. So let's say this is just for one day, right? So I could take this, and this shows, how many calories I burned, how far. I did treadmill, so how far I walked on the treadmill and the amount of time it took me. I could gather this data, and that's what I'm actually doing, for the week, right? And sort of average out. So you can make, let's say I wanted to lose a pound a week. I think you need to burn 3,500 calories to lose 1 pound. And so I could calculate, okay, if I burn 393, if that's my average, right? So you talk about average, that's descriptive. Then how much would I need to go a little deeper into inferential? Maybe I can do some more analysis, but descriptive is, okay, I can take the average. Let's say I do this for the whole week. So let's say I work out 3 days a week. I take all the different, calories for the week. So I average that out, distance, I average that out, duration. So all that you do, and I know some of you might have, I don't know if people still wear Fitbits, because I know the Apple Watch has taken over, but I still have a Fitbit. So you can do descriptive statistics on that as well. Okay. I wanted to also show you an example of inferential statistics, because this is, I don't know if you're into politics, the Iowa caucus is the election people. They use the Iowa caucus as a sample to predict how the election will go. And so I took this recently, I guess from January 2nd to 8th. They took a sample. Okay, they didn't take the entire population of Iowa, although I don't know the entire population of it. It could be small enough for them to do. I doubt that. But they took a sample and probably gave them a survey asking, okay, who would you vote for if the election were today? Who would you vote for? And you see how it's looking right now. And so then they make inferences to determine who will win the election. And I can't remember. I used to know this information, but I can't remember how accurate the Iowa caucus. I think it's fairly accurate. I'm not for sure. Don't quote me on this, but that's what they use. So that's an example. I just wanted, again, statistics just leads way to so many real world events, right? And so I just wanted to show you. So that's an example of how you would look at inferential statistics, right? Because we know the election hasn't, arrived yet. Please go vote. That's my spiel. But they're sort of predicting, because we don't even know who's going to be the running candidate, right? But they're sort of predicting this. Okay. So that's an example. We're almost done, actually. So I wanted to take a minute, and I want you to really maybe pause the video, because we're almost done. So pause the video and see, by reading each of these, if you can figure out which statistics is descriptive and which is inferential. So pause the video and then play it out, and then write down your answers and then play the video to see if you're correct. Welcome back. The world of, instant gratification. we're going to look at our answers. So let's look at A. In 2025, the world population is predicted to be 8 billion. It's predicted to be. So it would be what? Inferential, right? Because another thing about descriptive statistics, it's right there. You have that information right there, right? Just like I showed you that information on, my workout or whatever. I have that information. And if I, take notes of for the rest of the week, I can do averages, I can do mean, mode, all that. Okay. So that is inferential because it's 2025. It's not even 2025 yet, right? So they're making future predictions or inferences based on whatever data they have now. Okay. So that's inferential. B, in a weight loss study using teenagers at Wayne State University, shout out to my alma mater in Detroit, 52% of the group said that they lost weight and kept it off by counting calories. Well, this would be what? Descriptive, right? Because they had that information there, okay? They had these teenagers in this study, and they asked them the question about, well, how did you keep your weight off or whatever, or how did you lose weight? And 52% said it was by counting calories. So that's descriptive. C, a recent article stated that over 38 million U.S. adults binge drink alcohol. Okay, so again, that's inferential, right? Because I'm sure they took a sample to represent the entire population. They didn't look at all U.S. adults, right? You just don't have the time, you don't have the money to look at all U.S. adults and ask them, have they ever binge drink? Okay, so this is inferential. All right, D, the CDC estimated that for a specific school year, 7% of children in kindergarten in the state of Oregon had non-medical waivers for vaccination. So again, you're looking at taking this sample and estimating what is going on in the entire state of Oregon. So this again is inferential. Okay. And let's look at the last one. A survey of 1,507 smartphone users showed that 38% of them purchased insurance at the same time they purchased their phones. That information is right there, so this would be descriptive. Okay. Hope that made sense. I hope this video makes sense. I want you to do this homework. Okay? Yes, homework. I'm going to collect this on Wednesday at the beginning of class, so please write this on a separate sheet of paper. Do not turn in your notes. I will not take your notes because your notes are for you to keep. So I need you don't have to rewrite the entire paragraph. You can just write the question and your answers. I don't need to rewrite the entire statement. That's fine. But do not, I repeat, I will not accept it if it's on your notes. So that will be a 0 for your homework, and you do not want to get a 0 on your first homework assignment. All right, I will see you all in class. Go back over this, and we will move on to section 1.2.